Hello Industrial Automation World, I'm Mike with Scott Equipment Company. Today we're excited we have Julian from Satie System with us. He's going to tell us about their unique solution to building control panels that's going to save you time and money on all of your control panel builds.
Thanks a lot, Michael. Good afternoon, guys. Hope you're doing well. So my name is Julian Zell and I'm from Satie. And so Satie started in Europe in '97 by simply making an aluminum frame that is used in replacement of your back panel, wire duct, and DIN rail, with the main idea of saving time, saving space, and the bottom line is saving money. And so the system was patented in '97, and then they had shipped me to North America in 2005 with my sample and wishing me good luck. And so I landed in Toronto. Long story short, for a visa issue, I had to come to Canada instead of the US, but this is when we landed and this is where we set up shop. So we have a full shop in here where we have all the extrusion in 8-foot lengths. And the only thing we do is cut and assemble frame all day long. And so we started here in 2006 and we moved to a bigger facility in 2010. And just to give you an idea of the volume, we built around 15,000 frames a year. This year, we're hopefully going to reach closer to the 20,000 mark. And so I'm going to start with a quick PowerPoint presentation, and then at some point I'll stop to show you an actual sample I have beside me to make it a little bit more interactive and show you a little bit more how the system works. So just a little bit of how the system came about. So it came with a basic idea to try to improve the way control panels are built. They've been built the same way for the past 30, 40 years, and for the most part, it's still been a steel back plate where you gotta lay it out, drill, tap, cut your DIN rail, cut your wire duct before you can start to assemble your panel. So the idea was to try to eliminate those deals, all this mechanical work, as well as try to improve the available space inside of the cabinet, because if you look at it from the front with a traditional back panel using the wire duct is taking a good amount of space in the panel. So we try to combine the two by eliminating the labor required to build the control panel, as well as optimize the space inside the box, so we can either gain between 30 to 50% space, either to keep the same size enclosure and give you additional space, or being able to reduce the footprint of the enclosure. And so with that comes three main benefits. The first one is a time saving on the mechanical portion by not having to drill and tap, time saving on the wiring by having an easier access to the component and not having to deal with the wire duct, a space saving by making a better use of running the wire and not having the wire duct taking panel space, and then bottom line, we gotta help save money. So the first saving that we have is a time saving on the mechanical portion, as there is no need to lay out the panel, drill, cut, tap, cut the wire duct, cut the DIN rail before you can actually start to populate it. As in 99% of the cases, we offer a pre-assembled frame, and I'll go through the process in a little bit, that you take out of the box of the skid, put on your bench, populate with your devices, and you can start the wiring right away. The second section of the time saving is on the wiring, and the reason why is because we have an easy access to the connection point of the component, and the components are raised from the wireway, which means they are no longer buried in between two wire ducts. So the easy access and not having to deal with the wire duct and the fill rate, then that usually gives us, as a start, a 20% time saving, can go up to 30% time saving on the wiring portion. Second aspect of the system is a space saving, and the space is saved. Here we have a before and after of the exact same panel, the exact same usable space, and we just remove the wire duct from the front space and switch them at the back. And so instead of me trying to show you with my finger, I'm actually going to show you an actual piece that I have in here. Just back up. And so we try to show here a before and after of the exact same panel with the exact same usable space. So we wanted to do that on a smaller footprint just to show that even on the smaller panel, the way we run the wire allow us to save space, as this is the small panel with just small wire duct, but even with that, we can still have a space saving. And how we are able to do that is by using a little bit of the depth to run the wire. And usually that's a scary point when we mention the depth to run the wire, as you know, the depth is kind of the unknown of the panel, where people try to see, okay, what's happening at the back and how are you able to save the space, and especially how are we going to be able to handle the wires and be able to troubleshoot. So just to illustrate how we're going to do that is the panel space that's usually taken at the front and needing panel space, we're going to switch it on the side underneath. And the way we do that is just by how we design the frame. As the frame comes with a U-shaped bracket on each side that will raise the profile from the back rail. And these two channels that we have created is what we're going to use as a vertical duct. So when it's time to come and wire the panel, so we remove the cover from in between the rows. So in place, we have what we call a wiring comb that will accommodate the wire up to a 4-gauge wire, and then we can put up to 3 control gauge wire in it. So we have different type of profile to mount the component. We have the one that comes with a built-in DIN rail that come in different heights just to fit the biggest component on your row. And then we have what we call a flat version with a groove in the center where we can mount either a piece of DIN rail on one side, and then we have mounting bracket on the other side. So if we don't want to do any drilling or tapping, this will allow to mount any type of component by moving the nuts up and down and the bar left and right. And so same thing, the frame will come to you as is. You grab it, snap your components onto it, and then you can start with the wiring. So the wiring is always done by the front, as one of the misconceptions by using the depths is thinking, okay, I'm going to shovel all my wire and try to fish them at the other hand. Seems to be a good idea when you have access to both sides, but once you have your panel mounted inside the cabinet, it becomes a little bit more challenging. So I always emphasize on the way the wire run is pretty much the same way as using the wire way. As you're still coming from the front, snap your wire in front of your device. So to begin with, you have no interference to access your connection point because your duct is no longer protruding from the back and stopping you from having a clean access to your connection point. So it's an easier way to connect to the device. Then you run horizontally in the channel the same way you would do into the wire way until you reach the outside. Up and down, you use the vertical space created by the channel and then come back to the next connection point. So the way to route the wire with the frame is very similar to what we do with the wire duct. The only difference is instead of having the visual contact with the wire going up and down into your wire duct, you're now using the space that we create at the back. Once everything is done, you just snap the cover back on, and the only thing you'll see is the wire going to your device with your tag easily readable and accessible. And the way the system works, it's almost working with a 4x4 because the size of the cover that you have at the front doesn't define the amount of space you have for your wires, because actually you're working almost with a 4x4 all the time. So the benefit of doing that, you don't have no fill rate like the wire way, which means you wire everything a little bit looser and you can push the excess towards the back. What that does is, first, it's easy to wire, and second of all, it's much easier to troubleshoot or to do some maintenance, to add some components and whatnot once the system is installed. As the first thing you do is pop up the cover, and unlike the wire duct, the wire don't have the tendency to come out because they hold in the comb and then they're leaning towards the back. So easy for maintenance, troubleshooting, wiring, whatever you need to do inside of the panel, even after the panel has been installed. The space that you now have available, you have two ways to utilize it. So if the BOM is defined and is not going to evolve, then we can use the space saving to reduce the size of the enclosure. If, for example, it's a panel that's meant to evolve, then we can keep it in the original size, but we'll get 20 to 30% additional space in it that you can utilize for future addition in the future. The system is quite flexible, as it's kind of a Lego set where we have accessories, and here on the bottom right is just to show that even if you have designed the panel with DIN and DIN component, and all of a sudden you have a screw mount device that needs to fit on, if you were to do that with your wire duct, now here you have to cut your duct, make the room for the device, reroute your wire if they're already wired, and then fit your devices in it. In here, as long as you have enough space in the depths, we can add 2 brackets with a quarter turn onto those rails, and then we can virtually mount any type of component on top of it. So it's much more easier when you have to do changes and modification to an existing panel. And then once everything is done, the cover snaps on, and it gives you a nice and clean look to the panel with your tag easily readable and accessible. I'm gonna go back to the PowerPoint. Oops. And so this is the same view, but a visual version. But we don't have the sample, so that's the panel from the front that's already designed to fit the enclosure to which you want to put it in. They are raised from the back with those U-shaped brackets that we're going to use as a vertical ducting. So once it's time to wire from the front, in the comb, left or right, vertically on the side and come back. So exactly the same as you would do with the wire duct. And this is the view from the back. And same thing, those white wire holders are just meant to keep the wiring in front of the opening instead of sagging down to the level below. So this way we can segregate, and route the wire the same way as we would do with the wire duct. So the money saving comes from 3 things. The first part, it comes from if you reduce the size of the enclosure, there is a saving on the enclosure portion. No need for the back panel, wire duct, and dinner rail. You're going to save all the mechanical labor of not having to drill to tap to cut. Plus, you have a time saving on the wiring as well by this easy access to the component and not having to fight with the wire duct. And so the way the process goes is we take whatever you have available. So if you have already a layout done, that's a panel that you're already doing or you already done the engineering on it, we take the layout, convert it with our solution, and send you back a 2D render of a 3D model where we're going to put it inside the enclosure. We're going to add the components that are on the door just to check the clearance and make sure there is no interference. In this case in here, it's exactly the case of keeping the same panel size but giving additional space, as this particular customer had to upgrade the control panel and they had to add additional component, an extra computer and whatnot, because the previous one wasn't fast enough for their application. So instead of having to change the enclosure, rechange the chassis, attaching the enclosure, and so on, we were able to offer them those 30% additional space that they could utilize to add the additional component that they were putting into their panel. And so for them, it was a drastic saving because for the same cost of building the previous panel, they were able to build the new panel without any additional. The price of the frame was paid for by the time they saved by not having to do the mechanical, a faster wiring time, and plus the additional saving of not having to go to a bigger size cabin. On the example where we're going to save the space, in this case, like this is a defined BOM where we started from a 4836 and we're able to fit into a 3630. And so, depending on the situation, this is something that we do as well. Then in reality, this is an example where this customer wanted more space into his panel because the original one had the drive onto the side. There was a roll forming application, so usually in the dirty environment, their main focus was also to raise the bottom roll because they were pretty close to the bottom. So we were able to raise it by about 6 inches and put it on a 45 degrees angle to make it easy to wire. So the way you use the space and what you want to do with it is really up to you. And so when we do the exercise, we like to know what's the purpose or what would be more beneficial to you. Not necessarily the purpose, but what would be more beneficial. Do you need more space? Do you need a smaller footprint? Do you need to improve the cost as much as possible? This way we can design accordingly and make sure we bring the value that you're looking for. The segregation of the signal, so this is some accessories that we have where we can split the channel in half with what we call a half wire duct, for lack of a better term. And so we split the channel in half, which means you have one side for your low voltage, one side for your high voltage, and then horizontally that it's split in half. So this is the equivalent of doing double ducting into the existing panel, except we only take the space of one wire duct from the front instead of two. Before I show picture, to go back to the way the process goes, so If the panel layout is already done, we take it, convert it. If you haven't done the panel layout, there is no point of you working a panel layout and then for us to change it. Whatever you have available, ideally a bill of material and the original enclosure you wanted to put it in, then we can take it from there and generate the panel layout for you. If it's the first time working together, we like to see either a picture of a previous application or at least a bit of information as far as how you like to have it laid out. So you want your power on the top right, your control on the top left, your terminals at the bottom and whatnot. So we can really design accordingly. Drawing comes with a drawing number, which also becomes the part number. So at the end of the process, we increase the revision as every time we go back and forth to make some changes. Once you have the final version and you order it, the frame comes fully assembled to you without the components on. So it's been already decided to which enclosure is going to fit in. So the part will be machined accordingly to fit to the existing studs inside of the cabinet. If it's a modular enclosure, we'll catch the framing. If it's an enclosure with unistrut, we're going to catch the unistrut. And then a few pictures of application. So this is a company that does pilot plants. So in this case, they standardize on our system. So what they want is 45 degrees angle DIN rail for all the components at the bottom. In this case here, what they did is they used the color coding as we have the blue, and the light gray available. When there is no requirement for blue to be intrinsically saved, then we can use both colors. In this case, they wanted 600 at the top, 110 for the balance. They could have done AC and DC in different color or field wiring and panel wiring, depending on what's more beneficial. This particular customer doesn't want to do any drilling, so even the distribution block are mounted on a mounting profile. In this case, they turn 90 degrees because they wanted to go through the CT, but at the top right, we have one that's mounted normally and then just a straight down wiring. The drives are mounted with 2-track with sliding nuts, so make it easy to install. And then if they were not using the full row, we can still leave the hardware in it. So when there is future addition, it's easily done. And that's the control side of it, where we have the Honeywell PLC. The center profile is the filler that we can put a DIN on when we have a power supply that goes beside it. This is for a double door wall mount enclosure. So this frame comes as one piece. So it's the equivalent of the backplate that fits in it, with the benefit of being aluminum. So it's going to be lighter than the backplate just to begin with. In here, we split the section into two just to give additional vertical wireways to segregate the signal, as they want to keep the power on the left side and the control on the right side. So we are able to do that like this. If it was necessary to have more section, we could have done more section. Usually for 60 or everything more than 48 inches in width, we usually try to split it in half, except if your wiring is top-down wiring, because we don't want you to go 70 inches one side, fill the bracket, then come back and so on, because then we'll fill up the bracket and then it will be just extra lengths of wires for no reason. Another benefit of the system is usually there's only the two vertical pillars at the back that will have in contact with the back of the cabin, which means in this case here, they have a UPS at the bottom. So we stop the profile above and then leave the space for the UPS. What we can also do now is actually come to the cabinet from the back of the panel, because as a standard, you usually use the bottom of the side, sometimes the top, just because dealing with cutting the backplate and dealing with sharp edges is a pain. Now, by not having anything at the back of the cabinet, we can have a knockout underneath the cover right where you want it. So if you were coming with your control, you can come underneath your cover here and then connect to your PLC right away. Same with your power section at another spot, and you can segregate your wiring even coming in. And it also sometimes brings benefit depending where the panel is attached to the equipment. Sometimes there is a guarding around, so usually they have to cut the guarding somewhere to be able to access either the bottom or the side of the top. And I don't know if that's something that applies to you, but we have a solution where we can do back-to-back. So we have a double-sided pillar at the back where we can have a panel at the front, which is this one, and then a panel at the back, which is this one. So this is a company that does bottling machine. So front and back, front and back. And in this case, what we're able to do is, well, we save the time, we save the space. But with back-to-back panel, the painful part is the interconnection between the front and the back that most of the time needs to happen inside the cabin. Not too much space, difficult to go from one side to the other. So with our frame, because those two sides are into one section, you can do the interconnection outside of the cabinet and then just drop the frame and drop it in. So there is a drastic time saving to it as well. This is the view from the back. I'm often being asked, oh, it's going to be pretty messy because it's not contained. It's true it's not contained, but it doesn't go all over the place because those white wire holders keep the wiring up, horizontally in front of the opening. And then vertically, we have this U-shaped brackets. So the view from the back is not as clean as everything was tightened and tie wrapped, but at the end, it's the functionality. So the wires stick together as if they were into the duct, and they are much more accessible. And because they're not wire tight, they're much easier to troubleshoot. And so just as a summary, time saving on a mechanical, no mechanical work involved, drilling, tapping, cutting. On the wiring, much faster because the easy access to the connection points, no tie wrap, no fill rate. And then the space saving will help either to reduce the size of the cabinet or increase the available space inside. And then at the end, we get to help save money and improve the bottom line. And then one thing I didn't mention is the lead time. So for us, usually on the engineering portion, usually 24 to 48 hours, depending how busy we are. And then manufacturing time, usually up to 10 units is 3 to 4 days. So let's say to come to you within a week by the time of order, your frame gets delivered. And then you take it out of the skid or the box, put it on your bench, populate it, and you can start the wiring right away. And then that's it for me. And Michael, I believe you wanted to show the project that we are currently working on.
Yeah. Mark, do you guys actually have any questions at this point?
I guess one or a couple of questions.
Sure.
Is the way those are laid out, does that interfere with any kind of UL requirements?
Very good question. So the system is UL recognized because, of course, they didn't want to give us the listing at the end of the whole process because they told us that the system is custom made, so it's not the unique system. But we qualify under NITW2, so a component for control cabinet, and the condition of acceptability, it has to be used into a UL listed box. So, which is going to be the case anyways when you put the UL 508. So there is no issue of using the frame and be able to apply the UL 508 on it. There is no need to add anything to your file because it's not in the condition. So there is no need to spend extra money to add the system to your file, and it will be compliant with the UL 508. The spacing, as always, with the clearance will be the same as with the traditional system, but with the benefit, since we are clearing up the duct, if you have to leave 2 inches or 4 inches until the next obstacle with the wire duct, that means you need the 2 or 4 inches to your wire weight. With us, it's the 2 or 4 inches to the next component. So just by design, with the size of the cover that we have in between, we'll reach the distance right away. And so we not only accommodate for the UL spacing requirement, but we can offer the more compact version still following the requirement.
Okay, yeah, because the unique thing about our situation with the 2 production lines we have is that it's in a very narrow space, so you don't have a lot of height. So one of our concerns is that it would fit in the small space that we have depth-wise.
So you have a depth constraint, correct?
Yes.
And how big is your panel roughly?
What do you think, Dennis?
Well, it's probably about a 16-inch wide, 12 inches deep, and the component that is the tallest limiting factor of the component is a Kent safety controller, which is probably about 5 inches tall, and our space is about 5.5 inches tall, which gives us just enough room to bend a couple of wires over to clear the space. So it's very, very tight and compact.
All right. Well, that's usually where we strive, as in most cases, people give us the worst option that they have for us to show what we can do. So we have different options to accommodate for that. And I guess if I try to show you something with the background, they ain't gonna work out too good. So this is an example of the light version. And so the light version here, it's mounted on standoffs. Sorry, the light is not too good this way. But we have more play with the depths. Plus, we can take advantage of the shoulder studs that usually raises the back plate by about an inch. And so for us, we don't need to. So by using a crossbar to catch the studs, we can recess a portion of it below where the back plate we usually see. So between the combination of being able to play with the depths and being able to cut it out, let's say your controller is the deepest one, we recess it in to stick at the same depths as your back plate is, and then we use the frame for the balance of it. So the best way for us to do it is once we do the exercise, because we work with a 3D model, we're able to sketch it inside the enclosure with the different component on it, and we're able to see right away if there is enough clearance for us to fit it into your enclosure.
Okay.
So what kind of costs are we talking about? And going back to what you just showed, there could be some merit there. I need to look at it a little bit deeper, and I also need the electrical engineer to be a part of that. But what's the cost impact?
So usually on an overall, we usually have a saving of about 20% compared to what you're currently doing. So the frame looks expensive, but it's usually not that expensive when it comes to it. So a small panel like that, you're probably looking at $60, $70. So this is something, if you compare it to your back plate is going to be 25, 30 bucks. The wire duct you're going to put on it is another 20, 30 bucks. Plus the time it's going to take you, we're already right there. So we try to be price competitive, and with the benefit that we bring, there is usually a cost saving at the end of the project.
Right. Okay.
I think the only thing the thing that I would recommend is that we can take some good photographs of our enclosure, our drawer that we're using with some clearance, and it may even be possible to send you a defeatured CAD model that shows some of that area, so you see the space requirements that we have. It is tight. I won't deny that. But again, with the exception of our Keyence safety controller, I think there is probably a little bit of wiggle room that we can tolerate some of this. You guys don't by chance make wire harnesses, do you?
No, we don't. I've been asked often if we do. Usually we kind of partner with someone to do it because it's a slightly different business. So we usually don't deal with the wire harnesses.
Julian, I'm going to take control here.
Okay.
Can you guys see my screen?
Yes.
Okay. This is one of our OEMs that we work with. They do 40 systems a year, and there's probably 200 to 250 panels. Not like, well, there's 40 like this, and then there's 40 of another one. So it's done in stages. So this is one of their first panels that we decided to, do. And of course, we got our ink. If you split the panel right down the middle, you can see we've got a left side, two contactors, two motor starter protectors, or a distribution block over here, same thing. So basically, when we looked at this originally, they had two explosion-proof kill arc enclosures, and if you've been in the explosion-proof industry, you know how much those enclosures cost. And they had like this whole left section here in one with a power supply, and they had the whole right section in one with a power supply. Of course, the breaker and terminal blocks and the fuse here was also one in each of those enclosures. And what's missing off of this panel is the MER power supply, which they had one in each of those two enclosures. So when I started looking at this, and we showed them Satie, and of course, they started looking at it, and I was able to, working with Julian, we were able to get this down to one panel, which takes away, they've given me numbers just by doing that. They've given me numbers. They've thrown out numbers in the thousands of dollars. First of all, that we were able to save them just to get it down to one panel. Second of all is you know, we kept the panel. They gave us their bill. Well, we actually created the bill of material. As you can tell, they're using LS that they purchased from us for everything: circuit protection, motor control, Socomec, actually, you know, a fuse block here, and the Airco they get from us as well. So basically, this is a turnkey solution, you know, for those guys. And once we presented them with Satie, instantaneously, you know, this panel, they of course asked, well, since we're buying all the product from you, can you send me the panel, you know, with all the components mounted on it? And of course we can do that. So because everything just snaps right on your DIN rail. So one of our guys in the shop actually put this panel together in a very quick amount of time. We sent it up to them. Their guys wired it, and what used to be a 3-day process to build what you see in front of you is a half of a day. This panel, I know for a fact, costs less than $200 to do this. This Satie panel, you asked about pricing and things like that. This panel itself costs less than $200 to be able to just get the panel in. We do all the work up front. So if you do have a layout drawing and you have a bill of material and you tell me what enclosure it wants to, you know, you need it to go in, then we do all the work up front, and we'll send you back a drawing that will look, let's see here, that will look like this, and you'll be able to see what it's going to look like in your enclosure. And if there's something that you want changed, or, and this is an older rev of what you're looking at, if there's something you want changed or something you want moved, you know, we have the ability to do that. And then once you sign off on it, you know, Satie can actually go into production with it and do how many ever you need. And of course, you know, if you've got X amount you need, then, you know, we can do that, or we can actually, you know, keep a few at Scott Equipment for you as well if you need to do that. So, you know, we can do as much as you need us to help you do, or, you know, if you want to do the whole thing and just, you know, get the panel itself, you know, you can do that. But we do all the upfront legwork just to show you, you know, this is what we can do. How do you like this? If you want to move something around, we can definitely do that. And then, you know, we don't recommend, you know, purchasing like 10 or 20 of these at one time. You know, we recommend doing a prototype, which is what we did in this case. And then once, you know, you do the prototype, you get to bring it in, and if you want to mount the components on it, you can mount the components and look at it and, you know, make changes if you need to. And then once we get everything nailed down, you know, we can go into production with it. And, you know, I think the two product lines you guys were talking about are, you know, I think this would be extremely beneficial to you guys. Again, the labor savings, like you said, some companies do and don't really look at that the way they should, but I know for this company, you know, we saved them in the thousands of dollars is the number they've thrown out, and took, you know, build time from what used to be 3 days down to a half a day.
Julian, thanks for taking a little bit of time today to explain the Satie system to our customers and how your unique solution to building control panels can save them time and money. If you do have any questions about Satie system, reach out to your local Scott Equipment Company account manager or email us at marketing@scotteq.com. Be sure to like this video and subscribe to our YouTube channel for more great industrial automation videos. Thank you.